the equations of a quadratic. Thank you.
Hey, I was just wondering, was there a maths textbook in here?
Is
Are
there
they
any-
both yours?
No, that would be probably yours. All right. So what we basically discovered the other day when we started looking at this was the following: that there are two equations. There's one where you got y equals a, x take alpha, x take beta, and there was another one where you could have y equals a, x take h plus k. That was squared, I think. So there's those two forms of the quadratic formula that you need to be familiar with and using, alright? And so with a quadratic, alright, we know it's just a curved shape, and the curved shape basically will cut at 2 points there, alright, and that's alpha, and that's beta, say, alright, and then we have this axis of symmetry, and we have this vertex C point there. The vertex there. This here, depending how we could graph this one here, that vertice point is in fact HK. Right, so if you get given the vertice, it's actually easy to use that model. If you get given the other equations, it's easier to find your x and your y-intercept. Now, with this model over here, the vertice point for the x-coordinate for the vertex, the x-coordinate is going to be equal to minus b on 2a. Right, so, or it's halfway between your two x-intercepts. That's the other way of thinking about that. Alright? Now, just want to talk through this example here. Alright, so that's talking about sketching curves functions, and that's really one of our key things that we need to be able to do. Alright, so alpha, so this equation here, 2, x take 1, x plus 1, x take 3. Well, I know that the x-intercepts for this one here have to be negative 1, because that makes that 0, or 3. So they're my two x-intercepts. Okay, my vertice has to be halfway between negative 1 and 3, so that would be 1. So 1 to 3 is 2, 1 to negative 1 is 2. And then once I've got my x value, then I can put that into, and I can find my y value. So I put 1 into there. Alright, so 1 plus 1 is 2, 1 take 3 is negative 2, 2 times 2 is 4, times negative 2 is negative 8. Got the idea? Putting into that equation. So that gives me my vertice point. My axis of symmetry is going to be negative 1. And my y-intercept will be when basically x equals 0. It's along that line there. So 0 is going to be 2, 1 times by negative 3 is going to give you negative 6. So these questions here are asking you to find your x-intercepts, the coordinates of your vertice, your axis of symmetry, and your y-intercept. Now I will be definitely asking you to be able to do something like that for our test when we do our test on this topic. Let's just come to an example and we'll do one together. Alright, so pick one for me please. Let's do C. We've got negative 1, so we've got 3, negative 1, 2. So let's do that on that board over here. Alright, as an example for you. And then I'll get you to have a go at doing some of these. So let's say we've got y equals 3x take 1, x take 3. So the first thing I have to find is my x-intercept. So we know our x-intercepts occur when y equals 0. Right? So in other words, that's going to occur when x is equal to, what's going to make that equal to 0? This first term. If we look at our first term, what value of x will make that equal to 0? Yeah, so that would be when x is equal to 1. And this term here, what's going to make our x equal to 0?
Negative 3.
Well, negative 3 take 3?
No, just 3.
No. Alright, so x equals 1 and x equals 3. Okay, my x-intercepts. Now, my y-intercept is going to occur when x equals 0. Right, so when x equals 0, I'm going to have my y-intercept. So in other words, y is going to be equal to 3 times by negative 1 times by negative 3. So what's that going to be equal to? Negative 1 times negative 3 is in fact 3. 3 times 3 is 9. Okay, so that's going to give me an idea about that. I have to find my axis of symmetry, don't I? Okay, so I know my axis of symmetry must be halfway between my two x-intercepts. Okay, so my axis of symmetry so what's halfway between 1 and 3? X equals 2 is halfway between 1 and 3, isn't it? Okay, and so therefore my vertice point is going to be simply, my vertice point is simply going to be y equals 3. I'm going to put the value of 2 into the equation, so it's going to be 2 take 1. It's going to be 2 take 3. So then that's going to give me a value of 3 times by 1 times by negative 1, which will give me a value of negative 3. So my vertice point is going to be 2, negative 3. Right, so if I think about all of this information, I'm going to do a sketch of that. Right, so I've got my x-axis, I've got my y-axis up here. I'm going to have it cutting at 1. I'm going to have it cutting at 3. I'm going to have my vertice point down here at 2, negative 3. Right, it's going to be symmetrical there. It's going to cut at 9. So my curve is going to go something like this. It's going to have arrows on it. What do the arrows represent? It keeps going on forever, yeah, exactly. And then here I'm going to have my axis of symmetry. Oh, sorry. So this is going to be my axis of symmetry. We'll call it AS, and that's going to be x equals 2. So I've got all that information just from my curve. Now, you could graph that on your graphics calculator, and that will give you a graph like that. So technically everything I've done there you could get from graphing the equation and actually reading that information off the calculator. Alright, does that make sense? So if you want to check things out, let's just do that very quickly. We'll bring up the calculator. One of the things we tried to talk about was there is a reason for doing this stuff. It's a really useful mathematical tool to actually finding stuff. So we've got our calculator here. We'll just clear those. Easiest way to get rid of those functions. Alright, so if we go into here, we're going to put our function. Our function is 3 bracket x take 1 bracket x take 3. Alright, and then we're going to graph that. Alright, so obviously I can't see every part of that curve, so I need to just change my window. I'm going to make it go to, let's say my min goes to -5, and my max goes to 10. Alright, and graph that again now. And that will hopefully show you your y-intercept as well as your x-intercepts, and you can quite clearly see that that point down there is in fact negative, it's 2, negative 3, can't you? Right, so everything I can see from that curve is basically, that's going through 9 there, is actually represented by the equation. Now, bottom line is, I mean, you could cheat. You could cheat, I wouldn't know you cheated. Right, so the bottom line for doing a lot of this stuff here, you can use a graphics calculator to actually find the answers. Believe it or not, that's actually a valid thing to do, isn't it? Right. I'm going to give you 5 minutes. What I'd like you to do, I'll give you 10 minutes. What I'd like you to do is have a going at 2 of those questions from part 1 of 2A, of A, section A. So if we come to our textbook, so what I'd like you to do is any 2 of these questions from part 1.
What page?
It's on page, go to the top, page 15. So I'd like you to have a go at doing the actual x and y intercepts, axis of symmetry, and the vertice point. Alright? Like I said, 10 minutes. I'm going to do the first bit and then we're going to go through the next bit together. It's in the purple book, yes. Purple book. Well, it's on the board anyway, guys. You don't need your book. You can just do it out of there.